Here to talk about the wonder and the mystery of conscious minds. The wonder is about the fact that we all woke up this morning and we had with it the amazing return of our conscious mind. We recovered minds with a complete sense of self and a complete sense of our own existence. And we hardly ever pause to consider this wonder. We should, in fact, because without having this possibility of conscious minds, we would have no knowledge whatsoever about our humanity. We would have no knowledge whatsoever about the world. We would have no pains, but also no joys. We would have no access to love or to the ability to create. And of course, Scott Fitzgerald said famously that he who invented consciousness would have a lot to be blamed for, but he also forgot that without consciousness he would have no access to true happiness and even to the possibility of transcendence. So much for the wonder. Now for the mystery. This is a mystery that has really been extremely hard to elucidate, all the way back into early philosophy and certainly throughout the history of neuroscience. This has been one mystery that has always resisted elucidation, has caused major controversies, and there are actually many people that think that we should not even touch it, we should just leave it alone, it's not to be solved. I don't believe that, and I think the situation is changing. It would be ridiculous to claim that we know how we make consciousness in our brains, but we certainly can begin to approach the question, and we can begin to see the shape of a solution. And one more wonder to celebrate is the fact that we have imaging technologies that now allow us to go inside the human brain and be able to do, for example, what you're seeing right now. These are images that come from Hanna Damasio's lab and which show you in a living brain the reconstruction of that brain. And this is a person who is alive. This is not a person that is being studied at autopsy. And even more, and this is something that one can be really amazed about, is what I'm going to show you next, which is going underneath the surface of the brain and actually looking in the living brain at real connections, real pathways. So all of those colored lines correspond to bunches of axons, the fibers that join cell bodies to synapses, and I'm sorry to disappoint you, they don't come in color, but at any rate, they are there. The colors are codes for the direction, for whether it is back to front or vice versa. At any rate, what is consciousness? What is a conscious mind? And we could take a very simple view and say, well, it is that which we lose when we fall into deep sleep without dreams, or when we go under anesthesia, and it is what we regain when we recover from sleep or from anesthesia. But what is exactly that stuff that we lose under anesthesia or when we are in deep, dreamless sleep? Well, first of all, it is a mind, which is a flow of mental images. And of course, consider images that can be sensory patterns, visual, such as you're having right now in relation to the stage and me, or auditory images, as you're having now in relation to my words. That flow of mental images is mind. But there is something else that we're all experiencing in this room. We are not passive exhibitors of visual or auditory or tactile images. We have selves. We have a me that is automatically present in our minds right now. We own our minds, and we have a sense that it's every one of us that is experiencing this, not the person who is sitting next to you. So in order to have a conscious mind, you have a self within the conscious mind. So a conscious mind is a mind with a self in it. The self introduces a subjective perspective in the mind, and we are only fully conscious when self comes to mind. So what we need to know to even address this mystery is, number one, how minds are put together in the brain, and number two, how selves are constructed. Now, The first problem, is relatively easy. It's not easy at all, but it is something that has been approached gradually in neuroscience. And it's quite clear that in order to make minds, we need to construct neural maps. So imagine a grid like the one I'm showing you right now, and now imagine within that grid, that two-dimensional sheath, imagine neurons. And picture, if you will, a billboard, a digital billboard, where you have elements that can be either lit or not. And depending on how you create the pattern of lighting or not lighting the digital elements, or for that matter, the neurons in the sheath, you're going to be able to construct a map. This is, of course, a visual map that I'm showing you, but this applies to any kind of map, auditory, for example, in relation to sound frequencies, or to the maps that we construct with our skin in relation to an object that we palpate. Now, to bring home the point of how close it is, the relationship between the grid of neurons and the topographical arrangement of the activity of the neurons and our mental experience, I'm going to tell you a personal story. So if I cover my left eye, I'm talking about me personally, not all of you. If I cover my left eye, I look at the grid pretty much like the one I'm showing you. Everything is nice and fine and perpendicular. But some time ago, I discovered that if I cover my left eye, instead, what I get is this. I look at the grid, and I see a warping at the edge of my central left field. Very odd. I've analyzed this for a while. But some time ago, through the help of an ophthalmologist colleague of mine, Carmen Puliafito, who developed a laser scanner of the retina, I found out the following. If I scan my retina through the horizontal plane that you see there in the little corner, what I get is the following. On the right side, my retina is perfectly symmetrical. You see the going down towards the fovea, where the optic nerve begins, but on my left retina, there is a bump, which is marked there by the red arrow, and it corresponds to a little cyst that is located below. And that is exactly what causes the warping of my visual image. So just think of this. You have a grid of neurons, and now you have a plain mechanical change in the position of the grid, and you get a warping of your mental experience. So this is how close your mental experience and the activity of the neurons in the retina, which is a part of the brain located in the eyeball, or, for that matter, a sheath of visual cortex. So from the retina, you go on to visual cortex, and, of course, the brain adds on a lot of information to what is going on in the signals that come from the retina. And in that image there, you see a variety of islands of what I call image-making regions in the brain. You have the green, for example, that corresponds to tactile information, or the blue that corresponds to auditory information. And something else that happens is that those image-making regions, where you have the plotting of all these neural maps, can then provide signals to this ocean of purple that you see around, which is association cortex, where you can make records of what went on in those islands of image making. And the great beauty is that you can then go from memory, out of those association cortices, and produce back images in the very same regions that had perception. So think about how wonderfully convenient and lazy the brain is. So it provides certain areas for perception and image making, and those are exactly the same that are going to be used for image making when we recall information. So far, the mystery of the conscious mind is diminishing